Hi, welcome to Tech Ranch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithmic and implementation. Quicksort in ArrayList. So in this session, we are going to learn how to implement quicksort algorithm using ArrayList in Java. Now before we get into it, let's see what is in quicksort. Quicksort is a divide and conquer algorithm. It picks an element as a pivot or partition a given array around the picked pivot. There are many different versions of quicksort that pick pivot in different ways. Now, what is actually pivot? Pivot means first we divide the large array into the small. Now, out of that small, we pick one element and compare with another element of the smaller array. That subarray. So that particular array and the first element we pick is as a pivot. So always pick first element as pivot. Always pick last element as pivot as it is mentioned in this picture. Pick a random element as pivot and pick median as pivot. The key process in quicksort is partition. Target of partitions is given an array and an element of array is pivot. Okay, let's take a look in a simple words. You see, we have a large array which is divided into small array. That is called subarrays. Now, subarrays have low elements and high elements. So, first we have to pick low and high. Compare and see which one is higher and which one is lower. And swap. Compare it and swap it. So, this is how the quicksort algorithm works. It is an efficient sorting algorithm serving as a systematic method for placing the element of a random access file or an array in order. So, it depends what type of application you need to work for data structure. In such cases, you need to decide what type of sorting algorithm you wanted to apply. This particular algorithm basically has the best complexity as an n multiplied by logarithmic of n, where n is a number of occurrences for comparison. You are going to put it in your array. So the larger the array, the bigger the element, large number of elements will have the large number of comparison. But divide and conquer make it a little bit better. So based on that, this is our complexity is going to happen in this algorithm. Now let's take a look at ArrayList. ArrayList in Java is a part of collection framework and is present in Java util package. It provides us dynamic arrays in Java and it may be slower than standard arrays but can be helpful in programs where lots of manipulation in the array is needed. So ArrayList is a kind of primitive data type and where you have your own class and just make it an object and use it accordingly. As you can see here, the difference between the array and the array list, where array need to specify the size of array. You have to initialize the size and declaration has to be like this. Where in case of array list, it's just dynamic. You do not need to specify the size or initialize in a proper specify the size of array. Okay, so this is what the difference between array and array size. We cannot add more elements to array after mentioning the size in case of simple array, whereas in array list you can add more elements in array list object. So this is what actually the difference between the array and array list, and based on your application and requirement you can apply your array list or array for your application. Now ArrayList inherits abstract list class and implements list interface. So there are so many ways you can define and declare the ArrayList object in your application. ArrayList is initialized by size. However, the size can increase if collection grows or shrunk if objects are removed from the collection. Since it's a collection framework, so you can add and remove the elements as per required, and which is possible in case of array list. Java array list allows us to randomly access the list. You do not need to go in a sequence. You can randomly access the elements. ArrayList cannot be used for primitive types like int and char and string. We need a wrapper class for such cases. So this is all about the ArrayList. Now let's take a look at our project and application we are going to implement is quicksort using ArrayList. Now let's take a look at the implementation. As per the algorithm of quicksort, we know we have to first partition the array into smaller arrays and pick the lowest and highest and then swap it. So let's take a look at the live implementation of quicksort using ArrayList in Java. So this is my Eclipse IDE, and first thing first we have to have a class with a main method mentioning quicksort demo. Quicksort ArrayList demo with main method. As per our requirement, first thing we have to have an array list. So let's create an array list in the main method. So array list with name a list, and since it is a wrapper class, so we need to define it in the declare proper form in this way. It cannot be for the wrapper classes, has to be in a primitive data type classes. So we need to use proper class objects and new. We have to have an integer type. We are going to compare, and it is a number type. So this is how we are going to define the constructor and the object creation of ArrayList. It's showing me error because I have not imported my package for ArrayList, util package. So you can see now I missed I here. Okay. So once the ArrayList is created, next step is going to get the values from the user. So for that we can just print some message for the labeling. Implementation of using ArrayList. Okay, so we have created the class, and we have now next we need to partition the array. Assuming we have an array, now this array has to partition, and after partition we have to swap. So let's have a swap method first. Let's start from the micro operations, and for that let's have a swap method implementation where we are going to have an int array and int I and int j. I'm using the private because we are going to return type, using the return type, so that we just call it in the main method instead of doing it all operation in main. And AI, our array, is going to swap it with a j, and once this is done, then a j is going to assign to temp some variable int temp. So this will help you to simple swap the method. Now next method we are going to implement the quicksort by name quicksort method, and it has an argument of list so that we can just display the list, and we are going to have two variable which is going to mention that when it is swap, it has to be first divide. For sorting we have to partition it, so we have to first pick the pivot to from. So let's name it as a from and to, and in this method let's compare from is greater than equals to 2. So based on that, once this is done, if it is true, then it will return. You see? And if it is not, then it will go to the loop. And first thing, we have to define the pivot. The pivot is the number we choose from the list to swap and sort. So there are two operations basically parallelly happening here: partition and swap, and then sort. So we have to make sure our steps are following like this. So first we created the array list, next we sort, and then we display. So what is happening here? We are just checking and moving the pointer. We are going to first checking and moving the pointer next to compare and find out if it has any more larger number than that particular pivot. So I is greater than j is going to compare and check the loop until it is true. So for that, I plus plus and while and see the list of I, which is again compared to pivot. And once the pivot is done, it will increase your I variable, and again it will check for the next available higher number if it is for the smaller arrays, for your sub array. Okay, so it is parallelly working with two size of arrays. You see, and this is going to decrease so that it will pointer will move to the close to the first array, first element. Now once this is done, next step we have to increase the I and the j value, because the two sub arrays are going to find and swap again, and then we will swap our list with I and j, like to and from pivot. So this is about your sorting algorithm implementation. Now after swapping, we can call it our quick sort method again. Now what is going to happen in the quick sort again? Here, what are we going to do? We have to have a method overloading now. I can explain it to you why it is needed, because when we actually create a sub arrays, it has to keep it in a separate list so that it can be sorted, like something like, you know, we have a method and we have an array, and this array divided into two, and then what we can do here, we have another method of the same name so that it will return type. The difference will be is the structure and the signature of the method. Now what is happening here, we are going to have the quick sort method overloaded with the list of different array. Now this time like a length of array, based on the length of array, that means we are going to compare and sort the sub arrays. So what will happen here in this case, when we sorted out one list, one sub array, we can just keep it in a buffer and display it in the main and just call it simple. So this is what needed when we actually work here. What we are going to do here, we are just going to call this method, you see, and here, and we are going to make compare and sort two different sub arrays we created, j plus 1 and 2 for two variable. So you see, now once this is done, next we have to call it in our main method. You see, so far we swap, we compare and swap, and here we sort and display it in different list. You see, So now this is all done. All we need to call it in our main method now. So how is going to happen in main method? But before that, now let's call it in a main method. In main method, we created array list. Now we have to create string variable. This is my objective of this program is going to happen here is we have to have a string input from the user until the list will be added the elements. We'll keep adding the elements. I'll show you when it will be more clear when we actually show you the demonstration. Now before that, let's first create an object of our class by name quick. And we have created the object. We have created object for array list. And next step, we have to ask user to insert some string to asking for adding the elements, list of elements in your array. So unsorted elements. Okay, we have to mention list of unsorted elements. Some random values user can enter. Now once this is done, we need to have a comparison from the user whichever he's going to enter by keep adding elements until user enter stop. I mean, you can keep adding the elements, and if you are done, then all you need to enter stop. Okay, so this is what the instruction here. It is going to simple add elements in your array list until the user will type and stop. Now for the user, there are so many ways you can get the values from the user and define it. One of them is scanner and another is buffered reader. In this case, we are using buffered reader to understand how we can get the values from the user using buffered reader. All you need to just make an object just like scanner. We create an object of buffer reader and it is an IO object. So let's have IO package included in your class and for input stream reader. So just like scanner, we create an object of buffer reader and all you need to just have buffer reader object compared with the list string which user have entered. If we entered stop, then it has to stop and read the list from the user and whichever he's entered and equals you can just have another feature that it will be ignore the case. If you entered stop small letters lowercase, then doesn't matter, it's gonna be same. So that's the objective. And ignoring the case and pass the string, and that string will going to compare, and after comparison it will enter the variable, enter the elements. That means my element, so I can do one element equals integer is my primitive class, parse int is my integer conversion from list to integer since it is a list type. So we need to convert it into the primitive type. From wrapper to primitive, you can use parse int method. Array list, my array list is a list object and a list dot add. We need to add the elements until the user is not this. If this is a string type of input, so we need to have a double quote here. So this should work. And the read line basically is not a correct method. It is supposed to be. It's a case sensitive. things, so we need to make sure we have ignored. So everything has to be mentioned. Since it's IDE feature that it will auto correct it, all we need, and it is auto suggestions, so it's good to work in IDE. Now once this is done, that means that we are adding the unsorted elements into the array until the user entered stop. This is the feature of the array list that we don't have to specify the size of an array. It is dynamically added. Next step, we need to have elements array, element list array initialized. Basically, this contains your a list. Basically, whatever length of your array list after all process, after all this execution, you can mention the size. Now, this size is going to specified somewhere by the iterator object. Now what will iterator do here? It will repeat your procedure, a particular number of steps. So what we have to do, we got the elements. Now we need to repeat it until it is not stopped. Now once this is done, next step, for loop for our iteration, repeating the iteration. You see, it dot has next, because we have to keep comparing it, and once the comparison is done, you can simply repeat your elements list and swap and return it to the. See, it's very simple. If you see, all we are doing just partitioning, then repeat, and then swap, and then sort. So we need to just make sure we are not confused with array and array list. Since we're sorting, we need to have the arrays, so we need to convert your array list into the sort, and our method has arrays, so we need to convert it into the arrays list, and we are passing it to the, since the quick sort method is passing the element list, which is done here, if you see. So we need to convert and passing into arrays, and these arrays will further print your method. Just for this labeling, we are just going to have some spaces. Now once this is done, all you need to just display this time values after quick sort implementation. Okay, so far. Now once this is done, we need to display the sorted elements. So for displaying, again you have to run the same loop. Now the reason we have elements list array which is sorted now. So we have to specify the size, and once this is done, all we can display the array list now. You see, and elements list and J, since it's a 1D array, so all need to just mention the space. So this is my quick sort implementation. Now let's take a look what is the array error here. Add throws declaration. We need to have a try and catch block for better coding quality. Now this is what the implementation with the execution. Any number you can pass. ArrayList will have your random size. Now if I enter stop, it will give you the values after sort. You see, so first it will divide, and then it compare with making a pivot and find out the part after the partition. It will find out the pivot for the lowest pivot and the highest pivot, and then swap. And execution of quick sorting algorithm using ArrayList in Java. Important facts about quicksort: divide and conquer. It always pick first element as pivot, always pick last element as pivot, pick a random element as pivot, pick median as pivot. ArrayList is a collection, it is dynamically created. So this is all about the quicksort in ArrayList. Thank you so much for watching this video. Please subscribe to our channel and stay tuned for more upcoming interesting videos. For more assistance and source code, please contact TechCrunch2019@gmail.com. Let's make coding fun. Thank you.